Good morning to you all. Today will be the second topic that we will be discussing, and that is a frequency allocation of satellite communication. So basically in this session we will be discussing about what are the different frequencies that are being used in satellite communication and what will be the use, where we are going to use that particular frequency in which application. So this is going to be our topic. So as mentioned, we will be talking about the frequency allocation, and we will see the different services offered by the satellite communication with respect to frequency. So first, why we need to have a different frequency? As I explained before in the previous session, that if the frequency is same, the signal is going to be destroyed because of interference. So once we keep the different frequency, all communication device can work together if they are working at different frequencies. So avoiding interference. The second one will be the efficient spectrum use. The third is regulatory compliance. So it helps the satellite operators to adhere to national and international regulations promoting responsible and coordinated use of frequencies. So basically it is very important that we should not interfere with existent frequency allocations. For example, the FM radio is going on. So we should not generate a signal at a frequency of FM radio, because if we do that, that entire signal of FM radio will get interfered and your signal will be destroyed. So it becomes a very important that we follow the regulations that are being set up by the governments. The signal quality also is very good if the frequency allocation is done when there is no interference. Coordination, it facilitates coordination and cooperation among satellite operators to ensure seamless global satellite communication services. So we can easily coordinate, we can easily give that, okay, this particular area we can give it to education services, this particular frequency we are targeting to the navigation services, this frequency we are targeting to the GPS services, this particular frequency we will be giving it to say mobile communications. So in this way, proper coordination if we do this, our overall performance of our communication system becomes good, the signal quality doesn't degrade, and we can use the efficient spectrum efficiently. So what does spectrum efficiently use means? Like in a given frequency we want to add more number of people without compromising with the signal quality. So in satellite communication we can say we want to add more number of stations without compromising with the signal quality. So what we need to do is we need to allocate the frequency, and if we don't allocate it properly and the same frequency spectrum we keep all the different services, then there will be interference and all the signals will be affected. So it is very important that we allocate the frequencies based on applications. So this is the most important slide and we will go one by one. So basically the satellite band, we have named the frequency ranges L band, S band, C band, Ku band, Ku band, Q by V band and W band. So here if you observe, this is the frequency range. So it is 15252 to 1559 is in L band. Now it is a known fact that as the frequency increases, the path loss also increases. So basically mobile communications satellite, mobile is a very mostly used services. So basically we have given mobile services this particular frequency range. And as the frequency increases, the path loss increases, and when the path loss increases means you need a higher amplifier in the satellite which can amplify the signal to greater extent. But it is not always desirable to have a very high amplification, because sometimes noise will also get amplified. So we often choose the frequency which is less, because path loss for a lesser frequency signal will be less. So here basically mentioned as DL and DL and UL. So DL means downlink and UL means uplink. Uplink means ground station to satellite. Downlink means signal transmitted from satellite to ground station. So downlink frequency is 1525 to 1559. So this is the frequency used by satellite to transmit to the ground, and 1626 to 1660 megahertz is the uplink from earth station to the satellite. So the orbit will be geostationary orbit as well as non-geostationary orbit. So for L band, both type of orbit will be used, and the services that we will be using at this frequency will be mobile satellite services. Now let us come to S band. In the S band also there is a range of frequency, and DL, UL, DL, UL is being used. So it is very important, as I told you in the previous slide, we follow the regulations, and these are one of the regulations that uplink frequency should lie in this range, downlink frequency should lie in this range, and all the countries around the world have to follow those regulations. If they don't follow that regulation, then they will going to affect the other communication services. So these are the again geostationary orbit, geostationary, this is non-geostationary, written as NGSO. This is geostationary, this is NGSO. So what are the services? Broadcasting satellite services. Broadcasting basically means transmitter is one and receiver are many. For example, FM radio. For example, cable TV, direct to home. That is called broadcast. So here we are writing broadcasting satellite services as BSS. So fixed satellite services, FSS. This is again BSS. This is fixed satellite services. Now come to C band. C band is the frequency range from 3400 megahertz to 3800 megahertz. Downlink it will be used. For C band only downlink frequency used, geostationary orbit, and it is used for fixed satellite services. KU band, this is the uplink frequency, and these are the downlink. Any one downlink frequency can be used in that particular range. Again, all three orbits where we will be transmitting KU band signal will be geostationary orbit, and FSS and BSS will be used. So again here we go to Ka band. So downlink and downlink, two frequencies are there, and uplink frequency is given as 27.5 to 29.5. Again for this range, geostationary and non-geostationary both orbits are used. FSS and BSS is being used. So another frequency band is Q by V band. So this ranges from 37 to 38.6 gigahertz. So again both are downlink, and geostationary and non-geostationary is being used. The last one is W band. Again downlink and uplink is there, geostationary and non-geostationary orbit is used, and FSS has been used for this frequency range. So in this slide we will be talking about bandwidth. So frequency range is being given as 1 to 2 gigahertz. So bandwidth is 1. For mobile satellite services, basically less bandwidth is being used. So usually we are transmitting voice, so for voice transmission less bandwidth is required. Then NASA deep space research, again the bandwidth is limited because some sensors will be used, that sensor is going to transmit the data. So again bandwidth is less required. So as we keep on going to the broadcast sometimes means transmission of video signal, so we need more bandwidth. So you can clearly see as soon as we enter into the broadcast, then we need more bandwidth. More bandwidth will be required. So BSS, FSS is being used for 8.5 and FSS is being used for 13.5 bandwidth. So these are the frequency range, and these are the L band, S band, C band that we have studied. So in this session we studied about the frequency allocation, the applications of satellite, which application is using which satellite services, the bandwidth, all those things we have studied in the today's session. Thank you.